All right, welcome back. This is the review for the polynomials test for Algebra 1 Honors. If we look at number 1, given the formula and image, determine the part of the expression that is overlapped. So we've got an expression here, and overlapped is going to be the part where the two different shapes meet. So we have this sphere, or the ball on top. So all the way around up there, we've got the ball. And we have this cone down at the bottom, and they both share this base, and that base is a circle. So when we look at this function, when something is overlapped, we have to get rid of something because there's too much. So basically that circle is being used twice. If we take the volume of the sphere, or the area of the sphere, and then the area of the cone, we have to get rid of something. And we're getting rid of the area of one of those circles because there's two of them on top of each other. And the area of the circle is pi r squared. So if we look up at our formula, the thing that we are getting rid of is one of those pi r squared. So given the formula and image, determine the part of the expression that is overlapped is the pi r squared that's overlapped. Number 2, explaining the meaning of the exponent in the algebraic expression x plus y squared. Well, that squared tells us to do something special about that quantity, and it tells us to multiply that quantity x plus y by itself 2 times. That means x plus y times x plus y. Number 3, explain why x and 4x minus 3 are terms of the expression and not factors. So what's the difference between a term and a factor? Well, if we forget, let's look down here. We have an x, and then we have this 4x minus 3, and they're separated by a plus sign. So hopefully we all remember then that terms are separated by addition and subtraction. And factors are not. Factors are products. Alright, number 4, evaluate a minus b quantity squared and a squared minus b squared when a is negative 5 and b is 6. So we're just going to substitute. And when we look at this, we have a minus b squared turns into negative 5 minus 6 squared. We're going to follow order of operations. Negative 5 take away 6 is negative 11. We square that, we get 121. And we do the same process for the second function, or the second expression, a squared minus b squared. This time it's negative 5 squared minus 6 squared. Negative 5 squared is 25. Minus 36 gives me negative 9. Nope, not negative 9. Negative 11. Alright, how is the order of steps different for the two expressions? Well, for that we're just going to describe what we did. For a minus b squared, so for a minus b squared, you find the difference, which is the answer to a subtraction problem. Find the difference, then square the answer. For a squared minus b squared, you square first, then subtract. So we're literally, for that part, we're literally just writing down what we did differently between the two of them. Alright, number 5, simplify the following expression. So we're just going to look for like terms. Remember, like terms have to have same variable and same exponent. If they have multiple variables, they have to have the same multiple variables. So if I have 5x cubed y, I'm looking for another x cubed y, and I see one there. We're adding in between them. 5x cubed y plus a negative 4x cubed y gives me a 1x cubed y. Remember, we don't touch the variables. Those just tell us what to put together. Next we have 6x squared y, and I have a negative 3x squared y. 6 minus a 3 is going to be a plus 3x squared y. And my next one, let's see, this is gone, that's gone, that's gone, that's gone. So I'm left with 6x and plus a negative 4x. 6 plus negative 4 is a positive 2x, and there's my simplified expression. Number 6, same thing, simplify the expression, but this time it's a minus sign. We talked about in class. The first thing we want to do with that is distribute that negative 1. When we do that, we can get rid of the parentheses. So we got x squared plus 4x minus 5. And when I distribute the negative 1, I get minus 2x minus 5. And then we combine. There's no other x squared term. So I'm going to bring that down. Next I have 4x negative 2x. So that's just going to be a plus 2x. And then finally I have negative 5 minus another 5, which is negative 10. And number 7, Daniel has a garden that measures 10 feet by 8 feet. He's having a problem with wild animals eating his garden, so he decides to put a concrete sidewalk around the garden. Surrounding the concrete, he places a wood fence on all sides. Find an expression for the perimeter of the wood fence. So we're definitely going to want to draw a picture for this. So we have the garden, which I know the garden is 10 by 8. Then around the garden, he has a sidewalk, which is x feet. So this length is x, and this length is x. And then finally around that, he puts a wood fence. And the wood fence is going to be W and W. So what we need to do is find an expression for the perimeter of that orange shape on the outside. So we need to look at what is the actual distance. So what is this total distance? Well, the black part from here to here we know is 10. But then we have x more on this side plus x more on that side. And then we have w more and w more. So what do we have total? Well, we have 10 plus x, that's 2 x's, plus w, so that's 2w. So that's going to be my new length of the fence. And then we do the same thing for the other direction. So from here all the way down to there. So again, this side started with 8 plus an x, so that's 8 plus 2x, and then we have w and a w, so that's plus 2w. So the dimensions of my fence are 8 plus 2x plus 2w and 10 plus 2x plus 2w. So if we want to find the perimeter of that, we know that the perimeter of a rectangle is 2 times one dimension, so 8 plus 2x plus 2w, plus 2 times the other dimension, 10 plus 2x plus 2w. We can distribute. So I have 16 plus 4x plus 4w plus 20 plus 4x plus 4w. And if I combine all those together, 16 plus 20, no, actually we're going to do standard form. So we're going to start with the x's. 4x and 4x is 8x. 4w and 4w is 8w. And then 16 plus 20 is 36. And there's my perimeter of my fence. Alright, number 8. Garfield Elementary School has plans to double the area of their parking lot. The diagram below shows the shape of the new parking lot. Find an expression for the perimeter of the rectangular parking lot. So when I look at the picture, it already gives me all the information I need, because I know for a perimeter, I'm looking for a length, and I'm looking for a height. Well, I already have the height, and the length is going to be the sum of these two terms, which that's going to be 2x plus z plus 10. So my perimeter then of this shape, P, equals, just like on the last one, 2 times one dimension, so 3x minus 4, plus 2 times the other dimension, 2x plus z plus 10. Distribute. P equals 6x minus 8 plus 4x plus 2z plus 20. Combine like terms. In standard form, 6x plus 4x is 10x. Plus, there's no other z term, so it's just plus 2z. And then negative 8 plus 20 is positive 12. So there's my perimeter. Number 9. 9 and 10 are both multiplying polynomials. We're just going to be doing either one of the methods that we talked about, either distributive property, the box method, which we called Punnett square, or FOIL. So you can use any method you want. I'm going to show one example of each. So for number 9, write an equivalent expression to 2c minus 5 times 4c plus 2. I'm going to use distributive property. This can be 2c times 4c plus 2, and then minus 5 times 4c plus 2. We distribute. 2c times 4c, remember we're going to add our exponents when we multiply, so I have 8c squared plus 4c, and then I have negative 20c when I go to this side, minus 10. My like terms are here in the middle, and I get an answer of 8c squared minus 16c minus 10. Number 10, multiply those two expressions and then simplify. So this time it's 3 terms. I'm going to use the box method on this one. Remember we set that up. We make a box that has the same dimensions as the term. So I'm going to have a box that is 3 by 3. Along the top, I'm going to put x squared minus 5x and positive 2. And along the side, I have 2x squared, 3x minus 4. And then we're just going to multiply. 2x squared, so this box right here, 2x squared times x squared is 2x to the 4th. Moving to the right, that's negative 10x cubed, 4x squared, 3x cubed, negative 15x squared, 6x, negative 4x squared, 20x, and negative 8. So there's all my products. And then we have to find our like terms, and we discussed in class that if we have standard form, like terms are usually going to be on the diagonals, which they are in this case. So we're just going to add up the diagonals as well. So we have 2x to the 4th. This is going to be the final answer. 2x to the 4th minus 7x cubed, because it's 3 and negative 10. Let's see, negative 4 and this positive 4 cancel out, so I'm left with negative 15x squared. 20x and 6x is 26x minus 8. And there's my product. 11. Suppose a pool has a length of 5c minus 8 feet and a width of 2c feet. Write a simplified expression for the area of the pool in square feet. So if we have a pool that's 5c minus 8 and 2c. We're going to find the area by multiplying the two dimensions. So A equals 2c times 5c minus 8. Distribute. We're going to get 10c squared minus 16c. That can't be simplified, so it's just 10c squared minus 16c feet squared is my final solution to that. Number 12, simplify 12 and 13, simplify the following expressions. We're going to use our exponent rules. I'm going to start by just doing the first two terms. So remember, we just multiply the things together that go together. So x's with x's, y's with y's, z's with z's, numbers with numbers, and then we're going to add our exponents. So I have a 1/4 times x to the 5 and 7 gives me x to the 12th. There's a y, but there's no other y, so it's just y. And then z squared and z to the 3rd is z to the 5th. And then I can multiply that by the next term, or the next factor. So we're going to multiply numbers with numbers. 1/4 times 16 is just 4. X to the 12th and x to the 1st is x to the 13th. Y to the 1st and y to the 5th is y to the 6th. And z to the 5th and z to the 8th is z to the 13th. And that's simplified. 13, same idea, but this time I have a power of a product, and when we do that we have to distribute that inside. So you get 4 squared a to the 4th, because when it's a power of a product we're multiplying. Well, when it's a power to a power, which we have here, a squared squared, it's a to the 4th, and we have b squared. You can do the same thing here. We have times a to the 15th, b to the 12th. And then we're going to use the same rule from before. So I have 4 squared a to the 19th, b to the 14th. You can leave it like that, or we can go ahead and figure out that 4 squared is 16 a to the 19th, b to the 14th. Either one of those would be correct. Number 14. The right triangle shown needs to be enlarged such that each side is multiplied by the value of the hypotenuse, which happens to be 2x. So each of these sides is going to get multiplied by 2x. That seems pretty straightforward. 2x times 2x is 4x squared. 2x times 3y is 6xy, and 3y times 2x is another 6xy. It says find the simplified expression that represents the perimeter of the new triangle. Well, once again, we know that perimeter is, add up all the sides. So I have 4x squared plus 6xy plus 6xy. The only like terms I have are these 6xy's. So 4x squared plus 12xy is the perimeter of my new triangle. All right, and we're on to the last page. Number 15, using the rectangular prism shown, write the factors of the expression to find the volume of the object, and it's reminding us that volume is length times width times height. So the factors are going to be the base, or the length, which is y plus 12, times the width, which is y plus 3, times the height, which is z. And then we can definitely simplify that. We're going to use one of our multiplication rules for those first two. I'm going to go ahead and use the distributive property, kind of modify it a little bit. I'm just going to do some work in my head. So y times y is y squared. Y times negative 3 is negative 3y. 12 times y is positive 12y. And 12 times negative 3 is negative 36. That all still needs to be multiplied by z. But before I do that, I'm going to combine these two guys. So v, the volume, is equal to y squared minus plus 9y minus 36 times z, and then we can distribute that z inside. So v equals y squared z plus 9y z minus 36 z, and that's my volume of that rectangular prism. Alright, and then number 16, use the figure below. What is the simplified expression of the area of this shaded region? So the shaded region is the big rectangle, which we'll call A1, but then we have to get rid of the little rectangle, which we'll call A2. So the answer to this is going to be A1 minus A2. And in order to find that, we're going to have to figure out what is A1 and what is A2. So A1 is the product of 3x minus 4 times 2x plus 5. And A2, let me use a different color here. A2 is the product of x plus 2 times x plus 2. So we can go ahead and figure out what this is going to be by simplifying. Again, I'm going to distribute this out. I'm going to get 6x squared plus 15x minus 8x minus 20. Simplify 6x squared plus 7x minus 20, that's a1, and a2, x squared plus 2x plus 2x plus 4, simplify that, and I get x squared plus 4x plus 4, and finally my total area that I care about, I'm going to subtract these two values. So it's going to be a1 minus a2. So 6x squared minus 1x squared is 5x squared. If you need to write it out, it wouldn't be a bad idea to write that step out first. In fact, let's go ahead and do that so we can see what we're doing. Because remember, we had some special rules when we had to subtract. So 6x squared plus 7x minus 20 minus x squared plus 4x plus 4. Remember, there's a negative 1 here that we're going to distribute in. So I'm going to kind of do that part in my head. 6x squared minus 1x squared is 5x squared. 7x minus 4x is plus 3x. And then this is the tricky one, the one that we would probably make a mistake on if we aren't being careful. Negative 20 minus a 4 gives us negative 24. And we're almost there. Part B, what is the area if x equals negative 2? So we're going to take that answer from this, so 5x squared plus 3x minus 24. 5x squared plus 3x minus 24. And we're going to evaluate it when x is negative 2. So when we do that, we get 5 times negative 2 squared plus 3 times negative 2 minus 24. Order of operations, 5 times 4, because it's negative 2 squared, minus 6 minus 24. That's 20 minus 6 minus 24. 20 minus 6 is 14 minus 24. So we get an area of negative 10. And it's negative 10. We don't have any units, so we're just going to leave it as negative 10. Alright, so there's my area for when x is negative 2. Part C, we're going to take that same function, 5x squared plus 3x minus 24, and we're going to evaluate it this time when x is positive 5. So 5 times 5 squared plus 3 times 5 minus 24. Order of operations, once again, PEMDAS. 5 squared is 25 plus 15 minus 24. 5 times 25 is 125 plus 15 minus 24. 125 plus 15 is 140 minus 24. And we get a final area of 140 take away 24, which is 116. Part D, explain why either part B or part C is a better choice for the area. Well, what do we know about area? Area is the amount of space that an object takes up, and one of our answers is positive, one of them is negative, and something that we should know is that distances, areas, and volumes can never be negative because that doesn't make sense. So which one would be a better choice? Part C would be better because area must be positive. And that's going to do it for the review of the polynomials unit, Unit 6.